Alrighty, people. What we are doing is we are jumping into 10.2. This whole entire chapter is about two-dimensional figures, and we're going to be looking at area. Once we're done with two-dimensional figures in area, we are going to be pushing to three-dimensional figures in chapter 11. Today, we are moving to traps, kites, and rhombi. Okay? So first, it says, what is the formula for the area of a triangle, a rectangle, and a parallelogram? So what is the formula for the area of a triangle?
1/2 base times height.
1/2 base times height. A rectangle is, what do we get? Base times height. And a parallelogram is going to be base times height. Now, we have developed the formulas for many different figures using previous formulas we already knew. Make sure you guys are peeping at the board. So, for example, you already knew that a rectangle was base times height. Then what you can do is make a triangle like this in here, and you find out that the triangle ends up being half of the whole entire rectangle, therefore it must be half base times height. Because this little piece will fit perfectly in there, that little piece will fit perfectly in here, and that means that the shaded triangle is half. You can also do this with a circle. If you grabbed a circle and you cut it like this and set them next to one another, it's not perfect, but it starts looking a little bit more like a rectangle. Then if you cut it in more slices, it becomes more and more like a rectangle. So the way that you come up with the formula for a circle is by making the circle into a rectangle. The way that you go over and figure out the formula for a triangle is you can adapt the formula for a rectangle. Does anybody have any questions on that? So now what you guys are going to do is you have multiple of these trapezoids. For people who are at home, let me show you the trapezoids that they have. They have these trapezoids right here, and they have gone over and cut them out. Shift up. They've got these. They've got 3 of them, and they've cut them out. What you guys are going to do is just experiment with those trapezoids. You're going to get them. You can cut them up if you want. You can set them next to one another. You are going to try to figure out a way to develop the formula for the area of a trapezoid. You might use one of them. You might use 2 of them. You might use 3 of them. But just start setting them next to one another or putting them on top of one another or doing something, trying to figure out a way to develop the formula using formulas we already have. And the formulas we already have are 1/2 base times height, and base times height. I have labeled those as base 1, base 2, and the height. So you guys are going to tinker in your groups. People at home will be back with you in just a second. All right, people at home. I saw 2 different methods that kiddos used. Some kiddos went over and grabbed their trapezoid, and it looked like this. And then they got another one and set it next to it, and it looked like this. And they said, hey, it's now a parallelogram. And I said, that's cool. Well, what's the area for a parallelogram? They said base times height. I said, what is the base of your figure? And that was the 2 bases together. We had base 1 and we had base 2. So you said it was base 1 plus base 2. And I said, that's great. And then what is the height? Well, the height is just h, height. And then I said, well, what the issue here is this the area we want? And they said, no, that's twice what it is, what we want. So they went over and put a 1/2 here. So it was 1/2 base 1 plus base 2 times height. That was one method. I saw another one that I've never seen before. What the students did was they had their trapezoid. They went over and knew that this whole thing was the height. They cut that in half, and then they set it next to the other one. And you still ended up with, that didn't exist anymore, and they ended up with a parallelogram. I said, okay, what's the area of the parallelogram? And they said, oh, it's base times height. I said, what's the base of this figure? And they were able to say it was base 1 plus base 2. And I said, what's the height? Well, what's the height now of this figure? 1/2 of the normal height. And do I have to do anything, or is this just the area that we want? It's just that single figure, right? So both of these methods did an amazing job. We can call this base 1, base 2, and height. And the formula is 1/2 base 1 plus base 2. What do we call that when you add things together and divide by 2? When you take a certain number of numbers, add them together, and divide by the number of numbers. Finding the average. So this should make sense. You have one base that's too small, one base that's too big. Would it make sense to average the bases together? Yeah, so that's what it is. It's basically saying, like, if you got one base that's too big, one that's too small, average them. This is the average. And multiply by the height, and that will give you your area. Does anybody have any questions on that? Cool. Okay, so let's go ahead and do an easy one right here. So we know that this is a trapezoid. We need to go over and average the bases, and then we're going to multiply by the height. So one base is 2, the other base is 10. And remember, PEMDAS tells you have to do what's in the parentheses first, and then you can go over and multiply. And then that's being multiplied by the height. Anybody have any questions on that? So the bases together give you 12, and we're going to average them. So the average is 6. And you're going to multiply by your 8, and that gives you 48 inches squared. Does anybody have any questions on that? Okay. All right, let's go ahead and do 2 more together, and then you guys can work on some. So on this one right here, it is 1/2 base 1 base 2 times height. Average your bases, multiply by the height. That makes sense. What do I have? Do I have my bases? I do. Do I have my height? No. You're either going to use Pythagorean theorem, trig, or special right triangles. So let's put in the stuff that we already know. 7 plus 5, and then multiplied by the height. You can put the height wherever you want. The height could be right here, the height could be here, the height could be here. Well, it makes most sense to have a height where you get a right triangle. So you have a 30, 60, 90 now, but you need one side of a 30, 60, 90 to be able to find the other sides. What side do we know? Oh, the bottom is 2? Cool. So if the bottom is 2, once again, 30, 60, 90s are going to haunt your dreams if you don't memorize them. That is getting bigger, so multiply rad 3 times rad 3. Okay, so here is your 30, 60, 90. 1, 2, rad 3. Your brain automatically thinks rad 3 is bigger, but if you put it into a calculator, it's like 1.7, which means it's the middle side. But anyways, we end up getting 2 rad 3 here. 2 rad 3. So 1/2 of 12 times 2 rad 3, 6 times 2 rad 3. And what does that give me? 12 rad 3. Inches squared. Is it inches or meters or meters? Meters squared. Questions?
Why don't you do 12 times 9?
You can. You can do 12. Well, you'd say outside times outside. 12 times 2, which is 24 rad 3, and half of that is 12 rad 3.
Well, but like, would you bake that cake? Do people in like the tests, official tests, want us to fully solve it? Like, do they want us to do 12 times?
Oh, I see what you're saying. So here, I see what you're saying, baking the cake. So here's basically the deal. If you go over, you guys have learned about like significant digits, and you have the understanding that sometimes different levels of accuracy are needed. So sometimes just having the whole number is good enough. Sometimes to the 10th is good enough. Sometimes to the 100th is good enough. This allows my reader to be able to go as far as they possibly want. If you go over and round to the 10th, and then they're like, wait, no, we need it to the 100th, they would not be able to go back. So it's always best to give them the exact answer, and they get to choose where they want to round to. Okay, let's go ahead and do the next one. 1/2 base 1 base 2, which is averaging your bases and multiplying by the height. Do we have both of our bases? Nope, we sure don't. Well, if this thing is a rectangle and that's 14, what's it at the bottom? 14. So now we do have the bases. One of them's 14 and the other one is 30. I feel right? Okay. And now we just have to multiply by the height. We have 16 something and 20. Or how are we going to do that? We have two sides of a right triangle. How do you find the third?
3, 4, 5.
Is it a 3, 4, 5? Please.
4 times 4, 5 times 4.
Let's see. 3, 4, 5. That would be 5 times 4. 4 times 4. Yay! Okay, so you don't even have to do the Pythagorean theorem. You could if you wanted, but it's going to be 3 times 4, which is 12. Okay, so a student in class picked up on the fact that this is a 3, 4, 5 times 4. So that just saved us time.
Wait, so why isn't it 14 now?
Because this is the 4 times 4. 4 times 4 is 16. 5 times 4 is 20. And then 3 times 4. It's a 3, 4, 5 triangle times 4.
If it's square next to it won't all of it. Oh, never mind.
It's not a square, it's a rectangle.
Yep.
Cool. Okay, so now we have 1/2 of 44 times 12, 22 times 12, and I'm going to need a calculator for that one. 220 plus 44. 264? Is that right? Anybody get that? Is it 264? 22 times 12?
Yeah, because 20 times 40.
Okay, cool. What I did was I had 22 times 12. I did 20 times 12 and 2 times 12. And I added them together in my head. Anyways, there you go. Does anybody have any questions on that? I want people at home to go over and pause the video and try these problems. People in class, go ahead and try these problems. Glance up at the board when you're done and check your answer. I'll put the answers on the board. Do not just copy my answers, please. See you in a second, people at home. Oops, this one is supposed to be millimeters squared. Millimeters, not inches. Okay, for the first one here, I was just checking, do you know how to do the basics? So they gave you everything. On a test problem, I'd probably go over and throw in like 7 and 7 or something like that, just to see if you knew those didn't have anything to do with the problem. But anyways, you average your bases together. After you average your bases, you multiply by the height and you get your answer. Does anybody have any questions on that? The next problem is much, much more challenging because you have to use your algebra skills. We have a 30, 60, 90, so I jump around the figure. If this is 12, then that's 6, and that's 6 rad 3. So now we have everything we need. The problem here is you have 1/2 of one of the bases, which is 9, and the other base, a lot of people want to combine that and say it is 15 rad 3s, but that doesn't make sense. This is 6 rad 3s. Imagine 6 rad 3s, and then you have 9 1s. That's not 6 rad 3s. Imagine if there were 6 rad 3s up. And then I had 9 1s. They're not the same, so you cannot combine them. If it was 6 rad 3 and 9 rad 3, yeah, then you have a bunch of rad 3s, and you can combine your rad 3s. But as of right now, you have to treat it just like it was x plus 1, 2x plus 1, meaning they're not like terms, can't combine them. So here, combine the things that can be combined. What are the like terms inside those parentheses? You have 9 plus 6 rad 3. What are the two things that are like terms? 9s. So I was able to combine the 9s to get 18. And then on the outside, I had a 6 over here. So now I just said 1/2 of 6 is 3, and then I distributed the 3 in, getting 54 plus 18 rad 3. That had a lot of algebra in it. The next one, we have our bases, so I can set up the first part, but I need to know my height. So I use the Pythagorean theorem to figure that out. Now it's not a nice, pretty Pythagorean triple. It spits out rad 55. So I have 1/2 of 20, which is 10, times rad 55. Anybody have any questions on that? Okay, the next things that we have to go to are kites and rhombi. Let's go ahead. How are we going to do this? Let's see if we can develop this really quickly. The formula, I'll just give you the formula, and then let's see if we can develop it. It's 1/2 diagonal 1 times diagonal 2. So if you know your diagonals going all the way across, you multiply them together, and then you go over and multiply by 1/2. Why the heck is that, though? Let's see. How can I break up? Let's say this thing is a rhombus. How can I break this up? What two figures do you have? You have two triangles. Okay, so this triangle right here and the other triangle. This top triangle, if we call this diagonal 1, and this one is diagonal 2, the top triangle will have a base that is diagonal 1. Does everybody agree with that? And what is the top going to be? How much of diagonal 2? 1/2 of diagonal 2. Anybody have any questions on that? And what's the bottom one going to be? The bottom one's going to be the same exact thing. This is going to be diagonal 1, and then the height is going to be 1/2 diagonal 2. Anybody have any questions on that? So let's go over and add together the pieces. We know, what is the formula for the area of a triangle? 1/2 base times height. So I'm going to put the information in. 1/2 base, the base of this thing is diagonal 1, and the height is 1/2 diagonal 2. Then I'm going to add the other one, which is exactly the same. 1/2 its base, which is diagonal 1, and then 1/2 diagonal 2 would be the height. What happens when you have 1/2 of this thing and another 1/2 of them? How many will you get total? One of them. So 1/2 of all this stuff and another 1/2 of all that stuff just gives you a full one of those. A full diagonal 1 times diagonal 2 times 1/2. You see how we developed that formula? Well, we broke it up into 2 different triangles, and we just found out the area of each one of them and added them together. Okay? This also could have been, 1/2 times 1/2 is 1/4. 1/4, diagonal 1, diagonal 2. And then you have another quarter, diagonal 1, diagonal 2. What is a quarter plus a quarter? A half. And that's how we got 1/2, diagonal 1, diagonal 2. Does anybody have any questions on that? Now, sometimes they're going to give you everything, like this one right here. They're going to say, all right, I'll give you everything. If this is 8, then what is this whole entire diagonal going to be? 16. And then what is this whole diagonal going to be for this kite? We have an 8 and a 14. 24? Pretty confident on that?
Yeah, because it's 8 on the top and then 14 on the bottom. And then...
Is 8? Isn't that 22? 22. Okay, what is 1/2 of 16 is 8. 8 times 22. Calculator, please.
I got you.
What is it?
176.
176 inches squared. So when they give you diagonal 1 and they give you diagonal 2, this is super easy. You just put it into the formula. Now, obviously, you're going to have right triangles involved, and I'm going to make you use Pythagorean theorem and stuff like that. So since we're running low on time, let's go ahead and do the rest of the problems together. This one, you have everything. Initials, MM, can you tell me it's going to be 1/2. What is diagonal 1 going to be? We're on the you try part. 12, great. The 6 and the 6, that diagonal will be 12. What is the other diagonal going to be then? We have a 9 and a 3, 12. So that gives you 6 times 12, which is 72. Does anybody have any questions on that? Then obviously you're going to have problems where you have to figure out part of it. 1/2 diagonal 1, diagonal 2. Well, we have one of the diagonals. It is 12. We just need to know the other one. So I'm going to go ahead and draw that in. If the whole entire thing is 12, then what is this part over here going to be? 6. And you have 6, something, and 10. Is that a 3, 4, 5, 5, 12, 13? What is it? 3, 4, 5?
Yeah, that's 8.
3, 4, 5 times 2. So this one, you could have done the Pythagorean theorem, or you could just know that that is 3, 4, 5 times 2, which is 8. So what is the whole other diagonal going to be? 16. 1/2 of 12 is 6. 6 times 16 is 96, I think. 96 yards squared. Does anybody have any questions on that? How did I get the 16? Well, we found out that this piece of the right triangle, which is half the diagonal, comes out to be 8 because we used a Pythagorean triple. Could have also used Pythagorean theorem, but we had to double it. Anybody have any questions?
No.
Okay, let's go ahead and do this one. It's probably all we have time for. So we're going to have 1/2 diagonal 1, diagonal 2, and you'll have everything you need. The only thing we're not going to get to is just using 45, 45, 90s and 30, 60, 90s, which you guys know how to use. But on this problem right here, they tell us that MC is 20. So let's put a 20 there. They tell me BD is 12. So what is each of the pieces going to be? 6. Okay, so we already have one of the diagonals being 12. It's the 6 and the 6. But we need to know what the heck this thing is to be able to find out the other diagonal. We already have the 20 part. We just don't know the other part. How are we going to do it? Pythagorean theorem. And not only that, we don't even need to do the Pythagorean theorem. It is a what?
3, 4, 5.
3, 4, 5. 3 times 2, 5 times 2. So this must be 4 times 2, which is 8. And we now get 1/2 of 12 is 6. 6 times 8. What? So 28. 28. Thanks. I'll give you extra credit. That is 28. 6 times 28 is what? 168. Anybody with a calculator? 168 inches squared. Now, as I said, the only thing that we have not covered is the 30, 60, 90s embedded. You guys will be fine with that. People at home, thanks for watching.